Warm greetings to all of you. It gives me an immense pleasure to extend a very warm welcome to you for the first Ruhuna International Undergraduate Research Symposium 2022 on behalf of the Ruhuna Science Research Circle, RUSREC, of the Faculty of Science, University of Ruhuna, Sri Lanka. This event is hosted as a hybrid event, and I would like to pay our sincere gratitude for all of you present here today, physically and virtually, for gracing this special occasion with your esteemed presence. Now, I kindly request the following dignitaries to take part in the traditional lighting of the oil lamp. The chief guest of the symposium, the Vice Chancellor of University of Ruhuna, Senior Professor Sujeeva Amarasena, the Deputy Vice Chancellor of University of Ruhuna, Professor E.P.S. Chandana, the Dean of the Faculty of Science, Professor D.H.N. Munasinghe, the guest speaker of the symposium, Dr. Padmasiri Ranasinghe, the patron of RUSREC, Senior Professor Mangala D. Silva, the Senior Editor of RUSREC, Senior Professor Kanti Yapa, the Senior Treasurer of RUSREC, Senior Professor Dhammini Premachandra, the Senior Coordinator of RUSREC, Professor Sunanda Kodikara Arachchi, the President of RUSREC, Inomi Angela Gayashani, the Secretary of RUSREC, Eranga Rupa Singha, and an author representing the participants of the symposium. Thank you all. Now, I kindly request the audience to rise for the Ruhuna University Anthem.
Pavalana silaka dakune Niruvan pirikala terane Anuvan oradunu porane Sarasaviyai merune Sarasaviyai merune Vidya Shilpa Kala Dan Haravat Labamin Ganamana Karamin Panavat Desa Basarasa Surakina Oda Tegavat Minisun Vimulo Pasasana Gunavat බබලන සිරිලක දකුණේ නිරුවන් පිරිකල තෙරණේ පනුවන් ඔරැඳුණු පොරණේ සරසවියයි මේ රුහුණේ සරසවියයි මේ රුහුණේ යුක්තිය ශක්තිය බව නිති සිහි කර දෑගොත් කුලමල පටු මත පිඳ හැර නම රැක පරසිඳු රෝහණ පුරවර හිරු සඳු වෙමුලක් සරසවි නිලඹර බබලන සිරිලක දකුණේ නිරුවන් පිරිකල තෙරණේ පනුවන් ඔරැඳුණු පොරණේ සරසවියයි මේ රුහුණේ සරසවියයි මේ රුහුණේ
The Undergraduate Research Symposium, organized by the Ruhuna Science Research Circle, RUSREC, and we strongly believe that this symposium will give the opportunity to portray their research findings through oral and poster presentations and laying a good foundation for effective communication of research in their career. Now, I cordially invite Ms. Inomi Anjala, the President of RUSREC, to welcome you all officially.
A very good morning to all of you. Honorable Chief Guest, Vice Chancellor of University of Ruhuna, Deputy Vice Chancellor, Dean, Faculty of Science, keynote speaker, and the guest speaker, distinguished invitees, authors, and guests present here as well as on Zoom platform, and dear colleagues. It's a red letter day in the history of RUSREC, having organized the first Ruhuna International Undergraduate Research Symposium, which aimed at providing a global platform to share undergraduate research findings. The fragrance of flowers spreads only in the direction of the wind, but the goodness of a person with a great leadership spreads in all directions. We have such an inspiring personality as our chief guest of the symposium, the Vice Chancellor of University of Ruhuna, Senior Professor Sujiva Amarasena. Dear sir, it's with great honor I cordially welcome you to this inaugural session. We are extremely happy to have your presence as the chief guest today. I wholeheartedly welcome the Deputy Vice Chancellor of University of Ruhuna, Professor E.P.S. Chandana, to this occasion. You were the guiding light and founder patron of RUSREC 8 years ago. We celebrate your leadership and we cherish the way you influence us. Welcome you, dear sir. Faculty of Science, University of Ruhuna, is being navigated now with a motherly care. It is with great honor and pleasure I would like to welcome the Dean Faculty of Science, Professor D.H.N. Munasinghe, to this occasion. Your presence today is a great strength to us, madam. A great supervisor can take you to incredible heights. Dr. Julian Andrew of the French Institute of Pondicherry, India, the main coordinator of CEDRIC project, a leading research collaborator and a great research supervisor to University of Ruhuna undergraduates, is our keynote speaker today. On behalf of the organizing committee, it is with great honor and pleasure I welcome you, sir, to the symposium today. Are entrepreneurs born or are they made? I feel that it's a combination of both. I feel honored to welcome the guest speaker, Dr. Padmasiri Ranasinghe, a research fellow, Industrial Technology Institute, Sri Lanka, to this occasion. He is also an entrepreneur who is very successful in several commercial arenas. We are honored and blessed to have you with us, sir. I most respectfully welcome all our professors, deans, heads of the departments, all academic and non-academic staff, acting librarian Mr. Lal Pannila, administration staff to this occasion. Your presence here and on Zoom is a great strength to us. The masterminds behind today's show. Let me welcome the advisory board of RUSREC, the patron, Senior Professor Mangala De Silva, the senior editor, Senior Professor Kanti K.A.S. Yapa, the senior treasurer, Senior Professor Damini Premachandra, the senior coordinator, Professor Sunanda Kodikara. So, with immense admiration, I offer the most affable welcome to our dear sirs and madams. A well-wisher is not a word, not merely a relationship. It's a silent promise. Let me welcome. We do cherish your partnership and collaboration with a warm and a wholehearted welcome. Stars shine at night. Some stars shine at daylight. A warm welcome and a big congratulations to all the authors who are sharing their research findings today at technical sessions. We believe this will be a great platform for all of you to convey research outcomes to a broader audience. Ability to work in unison towards a common goal and doing simple things with great love and passion are the true ingredients behind success of a great event. I feel grateful to welcome all the office bearers of RUSREC and the conference supporting teams to this occasion. Also, we would like to welcome alumni of RUSREC, RUAC, with great honor and pleasure to this occasion. We believe together we can achieve more. Coming together is a beginning. Keeping together is progress. Working together is success. The fruit of your labor is sweet. The root of all goodness lie in the soil of appreciation. Last but not least, I welcome you all to our symposium today, and let's put all our effort to make this event a grand success. Thank you very much.
Thank you, Inomi. An idol of knowledge and experience is an inspiration to us all. He is Senior Professor Mangala De Silva, the patron of RUSREC, and I consider it a great honor to invite you, sir, to address the gathering.
Good morning to all of you. Senior Professor Sujiva Amarasena, the Vice Chancellor of University of Ruhuna. Professor E.P.S. Chandana, the Deputy Vice Chancellor of University of Ruhuna. Professor D.H.N. Munasinghe, Dean, Faculty of Science. Head of the departments, and the keynote speaker, Dr. Julian Andrew. The guest speaker, Dr. Padmiti Ranasinghe. Senior professors, other distinguished guests, dear students and participants. Actually, it's with giving my warm wishes as a patron of the Ruhuna Science Research Circle of the Faculty of Science. I feel it's special privilege and a great pleasure to have this first International Undergraduate Research Symposium of University of Ruhuna organized by RUSREC. Actually, it's in, when we go for the history, in 2015, the RUSREC, the Ruhuna Science Research Circle, introduced the first undergraduate research symposium aiming to create a scientific forum for the undergraduates of University of Ruhuna to confer their research findings while improving the inherent skills of independent research, communication, teamwork, leadership skills under the patronage of former patron Professor Samanchandana Dirivira. And the continuous effort of RUSREC has been brought the Undergraduate Research Symposium in 2018 to the national level. And in 2022, it is a special privilege to have this RUSREC International Undergraduate Research Symposium in 2022, indicating an important milestone in the RUSREC activities. The generation of knowledge through the research is highly important for the progression of the country. And the voice of the talented youth should be reached and loudly heard. The enhancement of innovative research skills of the undergraduates to the continuous encouragement and providing opportunities for the scientific communication is highly important to produce the talented graduates. So in this scenario, I believe that this conference will be a great opportunity for the undergraduates to speak the word, gain new knowledge, cooperate with global research communities. I know the organizing this event was really challenging, and I would like to convey my sincere thanks to the RUSREC organizing team, RUSREC advisory boards, editorial panel, reviewers, academic and non-academic staff members of Faculty of Science, and the RUSREC undergraduate community for their invaluable support. While extending my heartiest congratulations for the conference, I wish all the best to prospective presenters. Thank you very much.
Thank you very much, sir. It's an honor to warmly welcome Professor D.H.N. Munasinghe, the Dean of the Faculty of Science, University of Ruhuna, to address the audience.
Okay, good morning to you all. So it is my great pleasure to address this first Ruhuna International Undergraduate Research Symposium. First of all, I would like to thank the organizing committee, the Vice Chancellor, sir, Deputy Vice Chancellor, and the organizing committee, and the guest speaker, keynote speakers, distinguished guests, dear students. So actually, if we say that undergraduate research is a very important component in today's world as well as in our curriculum. So I'm happy to see that event is happening today because of the last 2 years we couldn't organize this event due to the crisis in the country. So we know that it's very hard even conducting research as well as organizing this kind of event due to the lack of funds. So therefore, I actually would like to thank the organizing committee. Even with many constraints, they organized this event in hybrid mode as an international event. So I'm proud about as a Dean of the Faculty of Science. In the Faculty of Science, we always try to promote research among our undergraduate students. Several years ago, we know that research is only confined to the special students. Now, gradually we introduced a course unit for third-year students to conduct research. And very recently, we know at under head grant, now even the level 1 and level 2 students, they have opportunity to carry out their research with an academic staff member. So that means eventually we trying to give the importance of this undergraduate research into the student community. So I am happy to say under that course unit, now gradually number of students are increasing to carry out research. And even they have different difficulties, they are trying to at least conduct very small projects according to during their undergraduate student period. So actually, undergraduate students are very important because there are numerous benefits for undergraduate students who get involved in research. Undergraduate research allows students to develop their professionally and personally in ways not possible through traditional lectures and laboratory courses. It helps to learn valuable skills for their life, such as to honor others' attitudes, their work, and also as research, to learn research tools that is last for whole life in their long-lasting abilities, and effective communication skills and analytical skills, and even respect to others' ideas. And also, secondly, research experience gives students an opportunity to get deeper knowledge of research techniques and process, apply classroom learning in real-world context, explore academic literature, and even with the meaningful relationship with the good scientists in the field. Finally, research experience allows undergraduate students to determine an area of interest to start their career as researchers. Through exposure to as undergraduate, many students discover their passion for research and continue to graduate studies as well as faculty positions. So we are also the same as we experience that. So I believe the students who are going to present their valuable research findings today, they already gain those benefits to their life. And I think the organizing committee I thank the organizing committee for creating this platform to present their research findings and just make an opportunity to share their knowledge. And finally, I thank all the organizing committee for their hard work, and as well as all the supervisors and the Vice Chancellor, the Deputy Vice Chancellor. They are always encouraging students to do research and for their benefits. So I wish all the students, all the presenters, and congratulate them. And also, I wish all of you a fruitful day ahead. Thank you very much.
Thank you very much, madam. Thank you for giving us valuable insights on research. The Deputy Vice Chancellor, Professor E.P.S. Chandana, was the founder patron of the Ruhuna Science Research Circle. He is a person of a distinct vision and a fountainhead of illuminating ideas. You have opened up many opportunities for us, and we are much grateful for your commitment through the years. I cordially invite you, sir, to address the gathering.
Good morning to all of you. The Vice Chancellor, University of Ruhuna, Senior Professor Sujiva Amarsena, the Dean, Faculty of Science, Professor Munasinghe, Patron, Ruhuna Science Research Circle, Professor Mangala, and all the senior academic staff members, distinguished guest of honor, keynote speaker, students, and administrative officers. So thank you very much for inviting me to this occasion. So it's a really honor, and I'm very happy that we reached this milestone, the International Symposium. We have been talking about this for a while, but there were many reasons that we couldn't have this organized. So, but now we are successful. So I thank Professor Mangala and the organizing committee for organizing this event under a lot of pressure and a lot of obstacles. So when we start this in 2015, so what we have seen, the lot of energy that undergraduates have when they come to the university. So we were talking about how to tap this energy, how to channel this energy in a useful way, in a useful pathway. And you all know that this energy is tapped by some politically biased groups. So that is a disaster. That's why we thought to introduce something very important to get the students out of this dilemma and direct them and channel their energy to a useful path. So we were successful at that time. So Senior Professor W.G.D. Dharmaratna, I must mention him as the Dean. He supported me and a lot to start this. So many students benefited from this. Now you all know that they began to start small research. They sharpened their skills, and finally they did PhDs, MScs, and they did some useful inventions and innovations to the country. So why it is important to direct undergraduates at the very beginning of their career to do research? So one important thing I have already mentioned is this energy we can use. Because when they have been selected to the university, the majority of students, they feel a sense of superiority. Sometimes this is unrealistic, but sometimes it is useful. So you have to use this feature, use this feeling in a useful way. When they have been given leadership with necessary guidance, so they will take this forward. And they are sending a very important message to the other students. And we know that how students were harassed and how students were blocked in conducting research. Some unions, they never allow students to come to do research. There are problems, but but majority of students, they break this barrier and come to work with us. So this is the good feature, and this message should be delivered, conveyed to other students as well. So this is one important thing, because driving students to or directing students to do a research, small research, not a big one, very small project, they begin to think in a different way. The buds of researchers. So we are in the classroom, in the practical class, we are teaching them, we are guiding them, but it is not enough. We have to get them into a different path. We are talking about out-of-box thinking, lateral thinking, many things. Curiosity, love of science, imagination, intuition, lot of important mental faculties important for the researchers or the graduates. So we can, by driving them to do a research, we can inculcate these important thinking patterns. They slowly learn. So now, what is the message we have to take to the society? I kind of request from these authors who published today and all the students, so invite more students to do small research, small projects. So these approaches are very important to shape their career. And it is a discipline, as we all know. Research not only gives the publication, it gives you a lot of discipline, a pattern of thinking, especially and we know that there is a lot of resistance to new ideas in this society. A lot of resistance. We all experience this. So when we train our students to face these obstacles at the very beginning, to face the criticism comes in two ways, constructive criticism and destructive criticism. I always teach students to get the constructive criticism and to bear the destructive criticism as well, and we can manage our career. So these are the important messages we have to take to the other students who are still thinking to come to the research field, who are still reluctant to come, by thinking various obstacles, thinking various by looking at the barriers they have to face. So please invite. Now you experience this. Now it's a publication in your hand. That is the material you have. But apart of that, you got a lot of experience. So which will be very helpful for shape your future career. So get more students into this, and they will be benefited. And we must think of doing a lot of applied research, invention and innovations, because now our country needs lot of solutions, because we are having so many problems without solutions. So what we can do, our small findings, small changes will be very useful to make a big change in overall context. Therefore, we must guide, we must train our students to do applied research, inventions and innovations. Please take this message to the society in this important day. So this is my message. I am very happy as the founder, patron of this society, that the level you reach today. So I am proud of it, that. And at the same time, let me thank the office bearers of this society, Professor Mangala, senior people, Professor Mangala, Professor Dhammini, and Professor Kantiapa. They were always with us from the beginning. They played a big role because they supported us a lot from the very beginning. I know that even yesterday, the Professor Yapa and Professor Mangala, they were working with the students, and so this is the happiness actually. So interacting with the students, this gives us a lot of experience, senior academics and the junior academics and students. And I must mention the current office bearers of the RUSREC. So they are very special students. Some of them are special students. They have a lot of work, but they dedicated on this. They have been working on this very hard. I know that. I appreciate your effort in this important moment. So I wish you all the best, and I wish all the researchers who present here today, present their findings today. Probably this will give a lot of insight to the future work, so we can work on that. And once again, thank you very much for inviting me to this occasion. So let's keep this momentum, work together, work hard, and try to develop our university as a very big research university. Your support is very much essential for that. And we have the leadership of our Vice Chancellor, is guiding the university in a new way. We have been released from a lot of pressures, from unwanted pressures. Now we can work very hard with a very clean objective in our mind. Thank you very much. Have a good day.
Thank you very much, sir. Thank you for your constant support and guidance you provide for undergraduates to conduct researches and shaping their soft skills, which indeed is very important for our career. The chief guest of this occasion is Senior Professor Sujiva Amarasena, the Vice Chancellor of University of Ruhuna. Your leadership, commitment and constant support for student activities inspires us all. Your priority and dedication have been critical to maintain high standards in the university. And I most respectfully invite you, sir, to address the gathering.
Very good morning to all of you. Senior Professor Samanchandana Edirivira, Deputy Vice Chancellor. Professor Hemali Munasinghe, Dean Faculty of Science. Senior Professor Mangala De Silva, Patron of the Ruhuna Science Research Circle. Keynote speaker, Professor Julian Andrew from India, French Institute of Pondicherry, and our guest speaker, Dr. Padmalal Ranasinghe from ITN. My dear heads of departments, professors, academics, and dear students, and all other members of the staff and invited guests. Let me first thank the RUSREC and the RURUS 22 for inviting me to be the chief guest on this occasion and address the gathering on this inauguration ceremony. Little remark on the empowerment. I think I am going to do a little speech on empowerment of students through research over the next 5 minutes or so. I knew I had trouble today. Faculty Day of the Faculty of Finance, Management and Finance. starting at 8 o'clock in the morning, and the RUSREC organizing Riverest 22. And on both places, I'm supposed to be the chief guest at the same time. So I was looking for a duplicate copy. So I asked Senior Professor Mangala, so who decided this? So he said, I decided this. So I admitted that. So that is democracy at its best. So my time and day is being utilized by others who are subordinate to me, and I am giving freedom for them to decide on what I should be doing at this time. And that's empowerment. I'm not going to allow anyone of you to do that in the future. That's a different thing. So I took it that way, because normally science research symposia I attend as much as possible, and it's been taken for granted. So I took it as granted. Fantastic, no issue. That's exactly what is empowerment for all of you. Research will empower individuals, societies, organizations and unions, institutions, countries with knowledge, with skills, with abilities, with thinking skills, analytical skills, and becoming open-minded at the end of the day. And that's extremely important for our country, and especially the future generation to be so. Because we don't seem to be learning from our past mistakes. People don't seem to believe data and information and science and research. So that's why I said we need to empower people, and especially students, and I'll come to that little later. I'll use a life experience on my own. I do normally use some of these experiences to teach people how things work. So I had 3 children, and it was trouble taking them to school in the morning. I'm sure all the parents know that. Getting them to wake up on time, getting them to get ready with their school bags, have breakfast, dress up, get into the vehicle or bus or whatever, and putting them there on time before 7:30 in the morning, before the school starts. All of you have gone through that trouble, and all of you have, I think, created problems for your parents during your childhood that way, and we have had the same experience. And I think we probably, I don't know, can't remember, not every day, we definitely cut the school, but so I always had problems of getting late. So I used research. So I gave a little book to all my children to enter data every day on the car, when you travel by car. So they start writing the time of departure from home, and 3 kilometers to one boys' school, Richmond College School, they write the departure time. Also in between at different junctions, they write the time. And then end, when I drop the last person in the school at Southlands, that drop-off time. We used this for about a month. The children were doing it. And I showed them that when they get late, everything gets late. And I give them the option of then choosing the path. Drop somebody from, the person who gets late will be dropped last. And that gave them a message. And they started changing. Of course, it was never a permanent change. I'm looking back at it. But the work world has changed them now, because they have understood to come to terms with the work world and go for work on time. But it was a research experience for children. They decided, they understood that when they get late, everything gets late and somebody suffers. And they were stimulated to change. But the change may not have been permanent. Probably the way we look at it and the schools look at it, and if the schools were doing something else for a few minutes delay, in arrival, then probably a lot of students will change. So that's how I used a research approach. May not be perfect scientific research. A research approach or data collecting approach to change young people. Of course, changing young people is easier than adults. Have no doubt about that. Problems grow with age. And big people are more difficult to change. So how to change people? I have gave them some experience. Now let me come to students. Of course, RUSREC and URES 22 are focusing on student research. And obviously student research are being guided by staff. This research will empower you. It will give you power. It will give you knowledge. It will give you information. Information for you to think and analyze, so that you will develop thinking skills and analytical skills. When somebody says something, don't believe it. Like when we have learned this from our childhood, from our heritage and history. We have learnt about that rabbit who ran when some palmyra nut dropped on the ground and created a big sound. And the rabbit ran saying that world is destroying. And then somebody stopped that rabbit and asked, why are you saying that? Where did you hear the noise? And went back to see it's the palmyra nut. How many times do we do this? As adults, believe somebody, go behind that person. We never learned that lesson from them. That story. Not only that, we have never learned that when rabbits sleep, turtles win races. We never understand it that way, that story. So that's ourselves. So we need to think about information, analyze information, and interpret information, and make decisions based on that information. That is a skill that you will learn with research, and you believe it, you will be hugely empowered with that ability one day in your life. Not only in scientific world, but also in day-to-day life and while working in the civil society. You will become a lot more open-minded for information with that approach. And then you will develop very smart analytical skills, totally different to all the others, and that will immediately create the impression that you are different and is above the other person. That's what matters in the work world. It's not only that ability that will empower you. I doubt a lot that large majority of you, the students, probably had never seen this Senate room before until it came to this organization. You never knew that we have such a nice Senate room in this university. So who would want to burn this? Who would want to sleep on this floor? I'm sure none of you would like to do it that way and destroy the Senate room. We have seen this in our country. We destroy our own heritage, our own buildings, our own property sometimes. And we've been empowered to come and sit in this Senate room, which had never happened probably to other students ever before, perhaps in some very rare occasions. And I would really like to see this room being utilized more often, especially for you to see this Senate room and dream one day to be a professor sitting on the chair. And that's empowerment. That's empowerment. To dream big. And also, while presenting, I understand there are 50 papers today, and in presentations you will now start thinking like a scientist. One day, who knows whether one of you will win a Nobel Prize, for scientific research in this world? I don't know. I'm thinking big all the time. I dream big, and I want you to dream big and get there. Because I can't do that. My time's gone. And I think most of the people who are sitting on this two front rows, their time's gone. So that's what this RUSREC organized RURES 22 will help one day in your career. So you young people, you have a huge potential, you have a huge ocean to swim, not a pond. Ocean to swim. Be a big fish in that big ocean and not in the small pond. So with that, let me wish RURES 22 all the best and thank the entire organizing committee, all the students for organizing this and make it happen in the University of Ruhuna physically or in the hybrid mode after COVID-19 related lockdowns and restrictions. And nice to see people back physically smiling at each other and regaining composure of the civil society. Thank you very much.
Thank you very much, sir, for your encouraging words of wisdom and for your insights on how research plays an important role in empowering individuals, especially undergraduate students. Now, we have reached one of the most important items in this inaugural session, the keynote address. I am profoundly delighted to take this opportunity to introduce the keynote speaker, Dr. Julian Andrew of the French Institute of Pondicherry, India. Dr. Julian has specialized in GIS and remote sensing and blue carbon ecosystems and published more than 30 full papers and several book chapters. Dr. Julian is serving as the main coordinator of CEDRIC project, under which a great amount of research has been carried to study the entire Sri Lankan coastline. He has served as a leading research collaborator in several countries, including Senegal, Brazil, and Malaysia. Presently, Dr. Andrew is working with University of Ruhuna, giving valuable opportunities to our students to develop their research careers. Sir, your expertise, experience, and knowledge will definitely be an excellent addition to our event as we are looking forward to hearing and learning from your work. I cordially invite Dr. Andrew to deliver the keynote speech.
biodiversity, not only the number of species, but also the functioning of ecosystems and the landscape configuration, the whole wide concept of biodiversity, knowing erosion. One important driver of this erosion loss is land cover change, mostly habitat loss and sensitive habitat for rare species, starting with forests. And forests have been changing in the world, mostly with loss in the forest cover, even if some areas are not showing progress. But it's also important, even as an environmental specialist, that nature is not anymore cut or can't be fully separated from societies. And the overall crisis in the environment cannot be cut from other social crises and social questions, like, for example, inequalities, where today in the world, a very small number of the richest people are accumulating the largest amount of wealth, and the larger people of poorest possess a very little part of the global wealth. And there is a huge stake in being able to link these two questions in order to think about more ecological world without making the social crisis even worse. Okay, that's why I will end up this introduction introducing the concept of sustainability science. My generation of scientists, and I'm not yet a very old scientist, is discovering new ways of doing research. And the concept of sustainability science is emerging, and I hope that your generation will be the one fully taking it as something granted and using it wisely. So sustainability science is research which is dealing with the interactions between natural and social systems. This is not fully new, but dealing also with how those interaction affect the challenge of sustainability. In other terms, how research can help meeting the needs of the present and future generation while substantially reducing poverty and conserving the planet life's ecosystem. That's a very wide objective and very optimistic, but it's important to have research designed to go forward in that direction. It's important that sustainability science approach also promotes solutions that contributes to rebuilding a sound relationship between human society and the environment. So it's not just research, it's solution-oriented practical research, which is the real novelty of the approach in sustainability science. It's not only to bring knowledge on the relationship between society and environment. Is to promote solution, is to build up a research that will be as fast as possible applied, which includes to bring knowledge that is required by decision makers and to there communicate in a broader range of communication than our usual job as scientists, which is to do peer-reviewed papers in scientific journals, which are most of the time only read by other scientists. The sustainability science include intersectoriality to be able to build our research knowledge with local communities, with local stakeholders, national stakeholders, international stakeholders, and only that can promote solutions to contribute to sustainability. Within the broad range of sustainability, environment monitoring is very important because even if, as I said, we need to build up science design, which going fast toward information for decision makers, it doesn't change the fact that science needs to be cautious, science needs to be prudent, science needs to be accurate, and we need to gather facts, data, and analyze this data in order to prove scientifically what we are discovering by science. And in order to be able to say that the environment is increases, we need to monitor the environment. We need to bring facts which are based on objective observation of the state of the environment. Environmental monitoring, therefore, need technology in order to monitor things, but also to be prudent in the approach of some notions. What is a reference state? When I say that there is less forest in 2022 than, I don't know, 50 years ago, it's a fact. It's proven by a lot of data, of actual data. But how and why 50 years ago is a reference state? What was the state of the planet in 1970? Who knows? It's even more dangerous when you think about concepts like initial state or baseline and concepts like nature and climax. It's very complicated in our world in 2022, where so many ecosystem has been deeply transformed by society, where the world is inhabited by so many human beings. Applying the concept of nature or climax to environmental monitoring is very dangerous, because we are referring to some states which disappeared thousands of years ago and is not helping in really understanding the actual dynamics, today's dynamics. So environment monitoring is a dynamic approach, focusing on the changes we are studying, what happened between in the gaps where in the last time where we have data. What happened as far as we got human memory, as far as we got memory from data from many systems of observation, and how can we put numbers and terms behind this change. We need to quantify things, but sometimes we need to qualify things, and this is not an easy choice. When do we need to put a number and when do we need to put a concept? Understanding trends, understand the hardest of it, understanding the drivers of the change, okay? Why has this been changing? Within environment monitoring, my specialty is geospatial monitoring, meaning using the satellites to be able to check the state of our planet, the ecosystem health, we can say, with the opportunity that some of the oldest remote sensing data is from the 50s, more or less, 70 years ago, if we take aerial photographies, even a little bit older than that. Satellite remote sensing started in 1972. So we've got 50 years of history, and it's been increasing. So remote sensing basically is a very powerful tool to environment monitoring, because in the old science, there are not a lot of data that have been gathered at this scale, which is global scale, since 50 or 70 years. Not a lot of disciplines can say so. And most of it, in this time frame of, let's say, 50 years, most of the remote sensing data is intercomparable, both in space and time. What I mean is that on one shot of any kind of satellite, taking one image, we can detect the same object in different places. We can recognize all the forest patches of a country on the same image. Therefore, if we are able to detect all the forest patches, all the water bodies, all the urban cities, we can map all the objects of the region. We can produce maps of land cover, habitat, stuff like that. But also, we can detect the same objects, kind of forest patch, in different periods, because we have the same kind of image, intercomparable, at different periods. Therefore, we also can map changes. in the location of objects, in the size of objects, in the shapes of objects, which bring us to the capacity of doing spatial analysis. Remote sensing have been evolving since the first vectors of images taken, the first planes where we put just a simple camera inside a plane, until the most recent and advanced satellites. At the beginning of remote sensing, we had a little number of data sets, usually with a low spatial resolution, meaning big pixels of hundreds of meters wide, and quite a low temporal resolution, meaning that the same satellite was passing over the Earth on the same place after a few months, or for planes after a few years. Now we have a very large number of very local data sets of high to very high spatial resolution, meaning that that's what you look when you are zooming on Google Earth, to speak simply. You can have a full of detail of an area, but then you move your screen few kilometers away and you have a very different image taken in another season with not exactly the same resolution. So you've got a lot of details, but you lost intercomparability, because when you're looking at, I don't know, I will take two places in South Sri Lanka, you look at Galle and then at Matara, you will find two different images with different dates and different resolution. And it will be hard to do accurate science in exactly mapping the extension of the cities, because you will have two free, very high resolution data, but difference between them. So I wanted to go back to tools that are not the latest in order to remind you the strength of this concept of intercomparability. So I wanted to show you how far we can go with an old data set, old in the sense that because remote sensing is inventing a lot of new kind of images and a lot of new satellites, everything seems quite old quite fast. Okay, so it's not science from 2 centuries ago, but anyway, it's already not considered like the most recent advances. But I wanted to show you how far we can get with it. So let's present what is the normalized difference vegetation index. Satellite is taking measures the same way I is doing the camera of your smartphone. So measuring quantity of light, of electromagnetic vibration in various bandwidth, like your camera is measuring the blue, the green, and the red, and rebuilding on the screen of your device the same colors as you were seeing with your eyes, and measuring separately the 3 elementary colors and rebuilding it on your screen. Remote sensing is doing that, but not only with the 3 elementary colors, blue, green, and red, but with other wavelengths. Some of them we cannot see with our eyes, but bring anyway a lot of information about the environment. The only one I will speak about is the near infrared, which is a wavelength just a little bit wider than the red, which is completely invisible to your eyes or any other senses of human body, but give a lot of information about plants. If you see the graph on the left, there is a green curve, which is labeled as a healthy plant. You see that healthy plants are having a little reflectance, a quantity of light reflected a little higher in the green than it is in the blue and the red, because a healthy plant is doing photosynthesis, meaning that the chlorophyll is absorbing the blue and the red light, but reflecting the green. That's why we see it as green. It's a basic chemistry of a pigment. But the important fact is the healthy plant is reflecting near infrared much more than it is reflecting the green. If our human eyes were able to see this near infrared, we would see plant in a different color, which is absolutely not green, because the quantity of light reflected in the near infrared is much stronger than in the curve. An unhealthy plant with a hydrical stress, for example, or any disease, is not reflecting in the near infrared, or much less. And if there is no plant at all, the ratio between the value in the red and the value in the near infrared is close to 0 or even negative. That's why a remote sensor invented decades ago a very, very simple index, which is the value of the near infrared minus the value of the red divided by the value of near infrared plus the value of the red value. It's just a simple formula saying that if the slope between red and near infrared is fastly increasing, there is a high value of 1. If the slope is fastly decreasing between red and near infrared, the value is -1. And if it's flat, we've got a value of 0. Between 0 and 1, we have a range of the most unhealthy, not dense vegetation, to 1, which is very dense, very high, and very healthy vegetation. And because it is satellite symmetry with remote sensing, we multiply the same simple observation thousands of times for a lot of pixels. In other time, we are doing regular maps with thousands, millions, billions of observations, one observation for 1 pixel, that we can project on a map with accurate geographical coordinates, and we know for a series of little places on Earth that remote sensing sees as pixels, a value of something. This something, in our case, is this normalized difference vegetation index. On any map here, we can see values from white to red. The red would be the high value of NDVI, the yellow's medium value, the green the low values, just showing that we can map this vegetation index in space. More interestingly for us today, we can produce the same map, the same image for the same measure for billions of pixels. We can reproduce it regularly in time. And that's what I want to present for you today, is how we can extract data, results, facts on the variation of this NDVI, of this normalized difference vegetation index, how it's changing for the same place in the last 22 years. So technically, the data we'll present is from the MODIS satellite. The full name is Moderate Resolution Imaging Spectroradiometer, producing a lot of data that has been cleaned up by the producers, basically the US NASA. The official technical name of the product is MODIS 13QY, which is the NDVI at the highest resolution and cleaned up data produced by the MODIS engineers, meaning that they are giving to the users, me, 1 NDVI values every 16 days. MODIS is taking much more images than 1 image every 16 days. This number has been computed as a window of time in order to make what they call a synthesis, showing, giving us for 1 pixel the value of NDVI accurate enough, even if, which you will see it with the next slide, still not accurate enough for me, but it means that when we compute data from satellites, our worst enemy is clouds. And of course, if you have a satellite way above clouds and you're studying vegetation under the clouds, you just don't have data. But satellite is measuring something anyway, but is measuring the NDVI of a cloud, which is a negative value. So we need a lot of images to hope, to try our best to have a value of NDVI measured from the ground or the vegetation, at least 1 day without a cloud. And we cannot wait 10 years before we have a value without a cloud because we lost the temporal resolution of the time series, but we needed some enough image to clean up the clouds. And the Modis decided this range of 16 days, meaning that 1 year is divided in 23 images, which is good enough to survey the seasonal variation of what we're studying, even crops and ecosystems and phenology. So basically, data looks like that over 2 years here. It's showing that this value is low when there is no vegetation activity at all, high when there is a very high vegetation activity of a dense vegetation. On the left, you see graphs quite chaotic with values going up and down, and mostly with moment very drastically low, which is places where pixels in some seasons where even after 16 days, Modis have found clouds for a series of pixels 60 times in a row. So there is still noise in the values. But if you make the exercise to smooth these curves, you see that you know where it's going up and you know where it's going down. And obviously it's going with the season factor, like alternance of rain and dry seasons. So we've got mathematical tools to clean up this kind of data. I will not go into details because it will be very far in mathematics, but the name is Fourier analysis, which is multi-cycle time series analysis, which reconstruct smooth and filter the time series in order to delete these errors. The first kind of result we can obtain with this kind of data is a bioclimatic classification. If we ask computer or software to tell us to divide the whole Sri Lanka into a small set, say 10 groups of pixels that behaves in the same way. It's asking, basically, we have a matrix of thousands of pixels covering the whole Sri Lanka, and as I told you, 23 images per year for 22 years. So hundreds of images and thousands of pixels. And we ask a computer to tell us which pixels behave in the same way in the time series. So we can get a map, you can see on the right, and curves we can see on the left. And giving for each region of Sri Lanka his temporal profile. Okay, let's take the extreme southwest of Sri Lanka, the evergreen humid region, which is a clear orange color in class number 7. You see the same curve on the graph on the left, showing that the greenest season is in February, March, and October, November, and it's a little bit drier, and vegetation activity is a little less important in July and August, which corresponds to the rain season of the southwest monsoon. If you take and class on the complete opposite, the class number 5, which is a purple, but there is various purple on this map, is quite clumsy from me, you will see that we can see where the vegetation is getting green only on the descending monsoon, the November monsoon, and we get the inverse curves in the NDVI values. We also can see some elements with very low NDVI values, simply because there is not vegetative places like sand beaches and other lagoons and stuff like that. We can see how is behaving the mountain ecosystem and on. So we can basically produce a bioclimatic classification, knowing where, how behave in terms of phenology, the forest, which is a biological cycle of the different ecosystems of Sri Lanka. And this works perfectly either for a natural, let's say, forest ecosystem or for a system of crops. If you have a system of rice fields, which would be green a bit after the rain season, and then be cut, you would find the same kind of signal with high value in when the when the rice is fully grown up, decreasing very shortly just after the cutting the rice, and staying with very low values until the next grow up of the trends. The second thing we can do with the time series analysis is to try to detect trends. The simplest mathematical way of detecting a trend is called the Mann-Kendall correlation. Mr. Kendall was an old scientist of the 30s, who was the first to invent that we could calculate a correlation between the rank, date 1, date 2, date 3, date 4, and the value of something, in our case, NDVI. So if you have low NDVI in the beginning of our time series, in the early 2000 years, and we've got very high values in the late dates of the series, in the 2020 something, you've got a positive correlation between low values in the low ranks and high values in the high ranks. If you had very high values of NDVI in the beginning of your time series getting lower and lower and lower, you got a negative correlation because you had high value of your NDVI in the low rank of your time series and lower values in the high ranks of your time series. This trend detection can go with some statistical tests to be sure that the trend we are detecting is significant statistically point of view. So let's look at these three maps. The first map on the left, you can have a shade of the colors between the darkest green to the brightest red, meaning the negative trends in green and the positive trends in red. On the map of the middle, you have in black all the values that are significant, meaning that the series is showing robustness in the variation of its data, and the p-value is null. And all the bright colors is data that might show a trend, but the test is showing that we cannot fully trust this trend, and maybe we should be cautious about it. That's why on the map on the right, we've simplified the map, keeping only the pixels with trends that are significant after the p-value test. So you see in red patches all the places of Sri Lanka where the vegetation index has decreased in time, which is something we call browning, going less green, so we call it browning. And in green pixels or patches, places where the NDVI has increased in time, which we call greening. So we've got greening and browning. As a geographer, the first thing I want to say about this map is that we have spatial autocorrelation, meaning that we have got patches very green, patches very red, and not a completely aleatory dispersion of pixels, meaning that we have got regions where something is happening, not just a bias in data. You can clearly see the region of Colombo as browning, meaning the values of NDVI are decreasing because in the last 20 years, a lot of peripheral neighborhood of Colombo were quite green, classical home garden, Sri Lankan home garden, getting denser and denser with the urban growth. Or we've got patches in the south of Trincomalee, but we'll talk about them later. We've got green patches in the south and the center of the island, but we'll go into further details. So for every one of these patches, we can compute statistics, see exactly how this value is changing in time. We can try to detect dates of breakout, in which year has the change happened. Have it changed in once with a high step of changes, or has it changed slightly with a lot of this long series of little changes? We can compute a lot of statistics to analyze this time series. So basically, most of the greening patches are showing a lot of little steps, so progressive changes, but this is obvious because we cannot go to a bare ecosystem to a very green forest in 1 year. Anyway, if it's greening, it's building vegetation, and building vegetation is always slow. So you have a progressive increase of NDVI. On the other hand, you can cut down forest in 1 day. So sometimes the decreasing is progressive. It's the example of urban growth, progressive urban growth, because you don't cut forest to build a huge city in one day. Sri Lanka doesn't do that. So it's slightly progressing from open urban with vegetation to dense urban with less vegetation. And in some places, we have drastic changes, like some settlements where vegetation has been cut out just in once to develop new fields, because this is the agricultural policy of any country. All the countries of the world can decide to cut a place of forest in order to have new fields, which is on ecological side, deforestation, on agronomical point of view, valorization of land. It depends on the generation you are. So maybe we can show little details, but I don't want to be too long. The case I was talking is an example in Colombo, showing that what I was saying about quite regular changes in the urban tissue. You can see in the early 2000s, the image from Google Earth was quite a green neighborhood, still city, but with a lot of trees. And in 20 years, the number of trees decreased, and we can detect that in the time series. If you see the graphs on the upper right of my screen, you see that, of course, the seasons have not changed. The rain is coming at the same season, and the trees are more active in the same season, which in this case is the month of November. So we've got changes which are progressive. We got one of the cases where I was talking about just 1 minute earlier, of one spontaneous vegetation, let's call it a forest, that has been clearly cut in one day for a new rural settlement, new roads, new houses, and new fields. So this is political intervention to give a living for people, which I'm not analyzing as a problem. As I was saying before, this is the political will of a country to ensure alimentary security. Food security. We've got some interesting cases when of greening. We all know how deforestation happens. Honestly, new fields and new cities are not the most original matter in 2020. It can be observed in the whole world. Greening is more original and more interesting. So in the Udawalawe region, we've had this quite bare vegetation in the early 2000s. And you can see on the graph on the upper left, very seasonal. It was quite dry with the very green season on the rainy season, going very dry vegetation, so savanna-like, let's call it that, but with little trees. And in 20 years, it has been completely covered with vegetation, including a vegetation which keep activity even in the dry season. So we have two changes, which is interesting. The first is simply an increase in vegetation cover, reforestation, but more interestingly, it's reforestation who also ensures greenness even in the dry season. So we also have a change in floristic composition. We've got some other greening processes in more rural sectors, not only national parks or protected areas. A lot of regions, this is Salamanawawa, in general in the Badula region and all the center east of Sri Lanka, has a lot of rural areas going greener and greener and greener, because a lot of crops are interesting in these last decades, like cashew nuts and hevea and rubber. So a lot of rural landscapes was covered by seasonal crops, which have not completely disappeared, but are associated with a lot of permanent crops and permanent tree crops, making the landscape greener and greener. And I suppose in this case, probably a new irrigation system, because as you can see on the upper right graph, in the early 2000s, the value of Indevii in dry season was very, very low, okay? Meaning that when the rainy season, when the water goes away from the soil in the dry season, vegetation activity is very low. Now, if you see the orange line in the upper right graph, the NDVI value is high all year long, meaning that there is greenness all year long. And if an agricultural region was very dry in the dry season and is now green all year long, it's probably because water is being brought in dry season. This is not climate change. Would have detected it in other regions. So we also can detect changes in irrigation patterns. As a synthesis, and because we've been studying the southern and eastern coast in the CEBRIC project, I will focus on the south coast and then on the east coast. Which are the main patches of changes detected with this method? Is the same series of drivers I've been identifying before. So we can find urban growth, we can detect the growth of gold, the urban growth of Matara, and we also can detect huge infrastructure development like the port of Hambantota and the airport of Matala. We also can see lines of the new highway and big major fresh roads. So we can detect urban growth, infrastructure development. We also can have side effects of this infrastructure development. Either, for example, we can detect a green patch in the Kalamatia Lagoon that has been studied by your university as consequences of changes in the sedimentation, which is consequences of the changes in the whole water basins, helping mangrove to cover more space than before and detected by this method as a greening. Or changes in the rural activity in Wediwewa, it was the whole valley is greener in this time span because just before the starting of my time series, it has been quite cleared up for future settlements, which has been going greener and greener with the growth of trees. So it's just, if the time series had been 10 years before, 10 years later, probably would not have been detected. On the eastern coast, we find quite a green line on the coast in the Batikaloa region, which is explained by two drivers. The first, there is this new kind of green touristic urbanism, a lot of touristic neighborhood with a lot of trees. And also there is a lot of Casuarina plantation on all the coastline, which are detected. These two getting merged into a simple patch of greening. And I wanted to end up with three patches of browning in the south of Trincomalee, which was also already visible in the map at national scale. In these three cases, we had in the early 2000 patches of spontaneous vegetation. And in these three cases, we've got now rice fields. Okay, so it clearly has been agricultural settlements and they all are the forest has been cut after the armistice in 2010, 2011. So they very probably some new settlements, some post-war settlements in order to reinstall population after the end of the war. But to show you how far we can go with this tool, it's interesting to compare not much how it was in 2000, but what it became in 2020. In this case, we had on the left image from Google Earth quite green patch of vegetation, and on the right you see all the new fresh rice fields or rice paddies. On the upper left graph, you see that it's dropped down very drastically in 2011. And on the right, you can see that it was an evergreen vegetation. And now we can see that rice paddies are green in November, which fits with the rainy season. The second case was also green vegetation, but more open. We're closest to the ocean. The change has been probably more regular in cleaning the vegetation. And because it was quite a drier area, the vegetation was not evergreen. It was drier in the dry season. So now the previous vegetation cycle was the same as the actual rice paddies. The third example is more interesting because it was very evergreen too. It was a wetland with mixing of wetlands vegetation, including some patches of mangroves, because there is a lot of channels from the river and inundated by the tide, which have been also cut in order to put new rice fields. But these rice fields are active months later because they are fully inundated at the rain season, and the rice is growing in counter season, in dry season, when finally the water is going away from the low part of the basins, and we have a counter season decrease of rice, which showing it's only 3 kilometers away from these two other patches, showing that we can also detect if we've got a rice season paddy crop or a decrease counter season rice, depending on the irrigation patterns, meaning that these tools also can have a full map of the irrigation capacities of Sri Lanka, detecting seasonal crops depending on the rains, crops that are enhanced by irrigations, or crops that depends on the increasing and decreasing of the water in the lowlands. In order to conclude, what all this data has brought us knowledge about Sri Lanka is that Sri Lanka is a country showing mostly stability. Okay, Sri Lanka is not a country where there is drastic deforestation at all, and I've been studying drastic deforestation in other countries, and Sri Lanka is not the case. My last sad travel was in Sumatra, in Indonesia, and if you want to know what is deforestation, you could study Indonesia. 92.5% of the island with this method at this time scale, and it's important to insist on that, was stable, okay? So this method showed that 92.5% of Sri Lanka was not showing significant changes in vegetation indexes. And in this 7.5%, more than 2/3 of it, something around 5%, is greening. So we've got mostly stability, and then the second most important change is greening, okay? And it's only around 2% of browning, which is showing not only stability, but even greening processes. Interestingly, the changes observed are very easily associated with human-made land cover changes. Okay, we are not detecting any climate change impact, which I was starting to look at the beginning of this study. And it's more greening than browning. And these land cover changes that have been detecting are mostly explained by national scale political decision. Okay, it's not like a deforestation front, illegal one, or not even individual scale changes in rural politics, like every landowner deciding to go from, I don't know, seasonal crops to cashew nuts. Most of the changes are on the wheel of politics, like infrastructure development and stuff like that. The new port, the new airport, rural settlements, the big reforestation program of some protected areas. So that's what I wanted to conclude on, and I hope that you have questions. Thank you very much.
Thank you very much, sir, for sharing your research outcomes and long-standing experiences with this audience. To appreciate Dr. Julian Andrew's valuable contribution to this symposium, I cordially invite the Vice Chancellor, Senior Professor Sujiva Amarasena, to present a token of appreciation to Dr. Julian Andrew. And I kindly request Professor Sunanda Kodikararachi to accept it on behalf of Dr. Andrew. Thank you, sir. We feel honored to have with us the guest speaker, Dr. Padmasiri Ranasinghe, Research Fellow, Industrial Technology Institute, Sri Lanka. Dr. Ranasinghe has specialized in natural products and developed several commercial products so far. Recently, his product called Raga, which is a beverage produced from Kithul, has made a revolution in the export market and has already become a popular drink in New Zealand. So, dear sir, please enlighten the audience by sharing your years of experience.
Good morning, ladies and gentlemen, Vice Chancellor, Deputy Vice Chancellor, and Dean of Faculty of Science, University of Ruhuna, and faculties and dear students. So I feel great privilege to be here and thankful to Dr. Sunanda and also the organizing team for inviting me to share some of my learned things and also my personal experience. Been 24 years plus of work in both as academics and also as inventor, which convert that to the innovations and also try to work with the business community and also the struggle with most of these regulatory authorities and to make certain scientific things into a business. So I'm going to talk on the multidisciplinary research and also innovation and commercialization, which is really a difficult task in this country, and I'll share some of my thoughts initiate certain arguments or debates, but still I hope this will create certain platform you to discuss certain things even in future in this category. All right, yeah. Initially, this bit of academics, there are research and experimental research. So most of you students and also we as faculties, we do this research, basically the experimental research, which are we call the control research, where we draw this from the hypothesis, from the research problem, then to the hypothesis, and we have control experiments, and then we draw the data and do certain analysis, we call the statistical analysis, to see whether we can get reliable answer to our research question or whether we can accept the hypothesis or reject the hypothesis. That's the technical definition of this experimental research, right? Let's see let's go another way. Yeah, this is the typical approach that generally we use when we have the research problem, right? That we need to find a solution. We are generally using certain approaches to do this, but initially we developed the hypothesis, the scientific way of looking at this problem, that is simply the hypothesis where we have certain measurables, and then based on this hypothesis, we develop the objectives of our study, right? And the objectives are certain, we call the goals or targets, where we need to do certain activities, we call the research plan or our activity plan, right? And with that activity plan, we're going to collect certain information, we call that data or our research finding, right? Then we need to use that research data because we need to verify that data to see whether these results that we get from this information is correct or wrong. So where we need actually, that's we call the statistical analysis comes into play. So we have both these things in combination, then we can conclude or we can get certain conclusion based on our data, and then we can see the reliability of our data to do a solution or do a basic invention. That's we call the new knowledge or a new information that we generate with respect to our research question and also with respect to the procedures that we followed in our research. So where these procedures also very important when you are for your reliability of your conclusion or reliability of your data, because where we need to follow certain standard procedures we called SOPs, and also your machinery and your instrument should be like incomparable or should be in line with the certain standard we call they should be calibrated, or they should be giving you the correct results, right? Simply like this, when you are using certain balance or a thermometer, if that is not giving you the correct data, the data point that you are recording is not accurate, right? Then even your hypothesis is very good, even your research problem is very good, even the methodology you followed is very sound, or SOP is very scientifically correct. If your laboratory procedures, your instrument and machinery are not reliable, if they are not giving, because we do not, when you read the temperature, we don't have mechanism to check whether it is correct or wrong, right? For these things now there are standard maintained. We call your instrument or a system should be calibrated, and you need to cross-check it. Even your balance, you need to check it again, and you need to calibrate it from the proper organization, and you should have standard chemicals to test. When you are running HPLC or something like that, you should have proper standard. They should not be outdated. And when you do this in the correct way, then you get the correct information. We call the reliable information. You need a reliable information to make it reliable invention. Because your invention is not reliable, you cannot plant it on earth, on the ground. That is the most critical problem. When you try to bring your innovation to the level of invention, I'll describe this later, the reliability of your data, reliability of your information is very crucial. So that comes with the two things, like that is your laboratory accuracy of your laboratory procedures, and also the way you're going to analyze this data. Just a heap of data tells nothing to you. So you need to analyze that with respect to your objectives, and also using appropriate statistical methods, right? Just to get the good results. When you have done all these things, then you basically have the then you have invention in your hand, basically. The invention is a new knowledge. Most of us is having this, right? If you follow the correct approaches with good SOPs, and if you consult a statistician or a biometrician, and when you do this analysis correctly, then you have reliable, good invention, which is your material to publications, maybe for your thesis. But when you want to bring that to the invention or into the commercializable item, you need to add a little bit more things, right? I'll discuss this in next 10-15 minutes, right? Where we need to nurse that, we need to add so many other things to make it into the commercializable item or a commercializable things, right? Where actually we need the multidisciplinary approach. That's where actually the multidisciplinary comes into play. At your first invention or your basic research, you can do it as a very small team within your chemistry group, or within your botany team, or within your physics, or within your sociological team. You can do that, your basic invention. But when you want to bring it to the invention, or to bring it to the commerce, bring it to the business, you need a bigger team to come into play, where actually multidisciplinary research is a must. That's why I titled this as a multidisciplinary research and also the commercialization, because you can do the invention with a small team, but it make into the innovation. Actually, when you want to commercialize it, multidisciplinary is the must. Then you need to make your team bigger, grow your team. How can? Right, yeah. Sorry, yeah. Okay, then I invite you to see some different things in different angles. Why all of the world, even in the morning, Vice Chancellor also talk about this innovation and research and these things. Why the world, today's modern world, is talking so much on this innovation and research? Why they have emphasis on this title so much? What is the reason? So before we jump into this, we should think, we should understand the reason behind why the whole world is talking about this, right? To me, the simply major reason is now in this world, the modern era we call the Industry 4.0 or industry world, or the knowledge-driven world, the knowledge or innovation is really a wealth driver, right? So the early days, it's the land ownership or maybe the more country ownership or money. That's something considered as wealth that you can create new wealth. But in this era, the knowledge based or industry 4.0 era, it's not the money or your land ownership or anything. It's the knowledge, it's the creation, it's the invention that's driven to you to earn more wealth, right? That's why the Western world is, or the other part of the world is more concerned on research and also in innovations. But we are not coming to that big state, big level. But when you see the world 20 or 100 companies, this is from 2018 data as I remember, right? Because I choose in 2018 or 19 data because COVID pandemic has changed the world economic landscape. So I wanted to use the much reliable data without that effect. So when you see this 10 or 20 company, you can see most of these companies are very new and also the technology driven. They are not the traditional oil mining or car manufacturing or nothing that. All these are the IT based, modern technology or a pharma based or this new technology based companies. They are this value of this one company is like maybe 10-15 times of our wealth at 1 year, right? This one of even the 20th company can buy whole Sri Lankan asset. That is the situation. Most of these companies are smaller than that. Their life cycle is smaller than 20 years, right? This is the gravity. This is the capacity of the innovation or the science or the technology when you come to the business. That's why they are posing so much pressure or so much attention on this innovation. And so it's not moving. Can you please go to the next slide? Right. So now there is a new concept. It's not very new. Concept is there which is called as a global innovation index. Right. Early days the countries are ranked by the wealth. Now there is a new term introduced by the WIPO, World Intellectual Property Organization. This is based on the one professor's invention. I don't remember his name, but popularly this is from WIPO. Right. They have used this World Innovation Global Innovation Index. Right. This rank your capacity of your country to make new innovation. This is not only the patents. Right. Don't misunderstand. This is not only the patents you file. In this innovation index, they use the basically two categories: innovation inputs and also innovation outputs. Innovation inputs, under the innovation inputs category, they use 5 pillars. Right, institutes, investment, human capacity, and the market sophistication and market intelligence. Under these 5 categories, they use the capacity of any state to develop new invention. And under output, they use 2 output categories. One is new creations, other is that is our technological inputs. Next one is a new creation like arts, music, like mental. Without experimental research, you can still make innovation. So that is the 2 category in this output. Next slide, please. I think where they are, you can find. This is from, when you go to the, student can visit the site. This is the WIPO, WIPO.org. This is the site. There is a big brochure. I got this from that brochure. So you even can download and read that. So this is where they highlighted this here. You can see this is the input part, this is the output part, and this is the input, this is output. Here you have this 1, 2, 3, 4, 5 pillars, and this is the 2 pillars, the scientific innovations and also the creative, mind creative type of innovation. This both, they use different criteria to evaluate. I'm not going to go into details. This is not my part. I just want to explain you how this is calculated. Right, this is annually calculated by WIPO, and there is a publications. You can get it from the WIPO site free of charge. You can download it. The Global Innovation Index ranking. This is a small booklet. Last 5 years, we are ranging we are hanging around the 90th position in this Global Innovation Ranking Index. Can you please go to the next slide? Yeah. Here you can see Sri Lanka is somewhere here in 90th position. When you see this previous table, remember this, most of the companies are from these countries where you see this at the top, the New Zealand, this Ireland, in USA, China, Japan, Korea also there. India also, I think, remember within 20th place, Pakistan, Bangladesh also before us. Right? We are 1980s, we are 89th. I think this year I just checked before coming, it's 94th or somewhere. Like we are still going down. Even our publication, rate of publication is going up. University and these things, publications rate is going up, but still we are not going in this innovation ladder because publication is not only the publication or a patent, it's not only the criteria they are checking for this innovation index, they are assessing it like using that five pillar system, which is really a comprehensive system just to check your in-house capacity to make creations and also assess the output based on that inputs. So we need to think on this actually even from the universities now. I know you have these university cell programs, and also we also have certain programs, but we need to focus certain things at national levels, and we need to develop certain strategies. Otherwise, we'll be in big trouble of still slipping down in this innovation ladder, and also meanwhile we lose science inventions, commercialization, and wealth earning in this country. Next slide, please. Yeah, this slide I put just to show you how we earn our foreign earnings, right? This is from the EDB in 2018. You see the technology-related business is the total ICT and other just electronic, these things, 11%. From our total export earnings, as I remember, something close to GDP, something close to 90 billion USD, as I remember, in 2018. So only 18%. 11%, not 11% contributed from the innovation and technology. All others are conventional sectors like rubber, tea, and also the labor. Its labor is also not the professional labor. It's a non-skilled labor. We are sending to the Middle East and other countries as a housemaid or a driver or something like that. It's not the professional labor. So we need significant shift in this. This is what happened to us. That's why we unfortunately got bankrupt. It's a part of the story. There's other part of the story, but there's one part from our sides also. So we need to increase. There is a small contribution from ICT, but other than that, not significant contribution from the scientific things, right? So I need to ask the question again: why we are still in the old version of business, right? We like still at the conventional agricultural business role. We are really adding values and things. So we'll see how and what we can do for this. Next slide, please. Right. Basically, because we fail to contribute sufficiently from our inventions to the national economy, right? Then when I check, this is my sort of my classification. I derive this from the WIPO GII scheme, but we don't have exact matching to the Global Innovation Index, this criteria. So I just list this like we have issues of extent of investment, human capital, scientific research, work climate and culture, business climate and innovations, and also regulatory and policy issues. Actually, today I'm going to discuss mainly on this part, the scientific research and climate culture, because we cannot, that's what we can change. This is bit like a hen and egg story. We are telling that we don't get much in like investment and from the government side, and we cannot, the government policy people, I know, they are telling that we are investing on, no, you are not putting anything to us or to the economy, right? This is going on here and there. So basically, we'll see how we can change, at least from our culture, so at least to make some impact and say, if you invest more, we can contribute more. So for that argument, so we will basically look at this part more and discuss other things very briefly. Right, next slide, please. Right, this is from the R&D expenditure at the global scale. You see, this is the Asian region. This is the middle level countries. This is the countries where you find at the top of this innovation index table. Right here, generally in our Southeast Asian region, they spend 0.6% of their GDP on research and developments. For other countries like middle level countries, they use 1.6. The developed, so it's not the developed really, it's innovation driven countries like where you can find top 20 index countries in top 20 in your index. They are spending something close to 3% of or 4% of their GDP. Their GDP is also 100 times maybe higher than us. From that also they are putting maybe very much high proportion than us. This is our regions. Next slide, please. We are actually spending very something close to 0.03, as I remember, 0.03 in 2018, which is less than the 0.6 of our regional value. Regional value is 0.6, Southeast Asian value region. But in Sri Lanka, we are putting somewhere close to 0.03, right, which is a very small proportion from scientific investment. Again, I am not telling that even you put huge money on science, still we cannot bring our country out of this situation. Reason is that putting only the money will not help. So putting money with real plan and also with the human capital. So next thing, next slide, please. Next thing we need to discuss is the human capital, right? Human capital means this is also calculated by, again, the WIPO also. The full-time scientists, they are calculating the number of full-time scientists per million of your population. That is the index. The full-time scientist means, like Vice Chancellor sir, even you are scientists, if you are sitting on your admin table, so now they are not calculating your time as a active scientist, scientific times. They calculate that based on relative involvements of your time. They have index, right? If you are putting 1 hour, 1% of your time, then they are taking only 1% from your time, because we have scientists, many scientists who are sitting at the admins. Even the university times, we know mostly we are doing admins. That's why we are losing significant time of scientific research time, because when you do the PhD, postdoc, and having been qualified, and then you sitting on the admin table fighting with others, and the student doing the same. This is a bit of criticism, but we need to do this, at least in the small community, right? I also did that for 6 years, and then I got back from the management, and now I'm working in the bench. So that's why I was able to do this Raga thing also, because otherwise this is not possible, right? So the innovation, this relative human index also issue. So next slide, please. So this is the human capital they define. The number of researchers per 1 million of population is considered as an indicator of human capital on R&D. We are well behind the Bangladesh also. Bangladesh, next slide please, I think the values are there. Right, here are our regional values. Here are the values in this top 20 countries in the Global Innovation Index. Right, there you have in our region, we are something around 130 to 200. Right, in Sri Lanka, as per NSF report in 2019, we have less than 100. 100 per 1 million. Next slide, please. I think I have put that. No, there should be one. Yeah, okay. Here you have this classification here. It's called FTE, the relative frequency. This is how they calculate it, and this is the global distribution. You see this darker area where they have more than 200 scientists per 1 million of population. We have very less than 100. Next slide, please. Yeah, it is there. Yeah, I got this from NSF. This is the breakdown. Again, when you divided by our million thing, this just comes to 112, roughly 112 per 1 million of population. So that's where we need to develop human resource and retain it. And also, meantime, even this index doesn't calculate the scientists just with the degrees, with the science degrees. They should get practically involved in science. So we need to think that also when you are doing the policy things. Next slide, please. Right. Then we need to think a little laterally on this research, work and climate and research work culture and climate, right? Because we rarely have this research culture, and also that is not supported by the national institutional policies, right? Actually, we even now see even the postgraduate student now they come by 8 and go by 4 or 4:30 from the lab, right? This is not a scientist is not a office type job. That's why I'm talking about this culture, right? When you go to the postdoctoral or a PhD, you know we work till 9 at the lab and next day also come by 7, right? Even our professors were there. They are there until when we go to the lab. My postdoc was in Japan, so when I go to the lab, professor was there. Even I leave even by 10, still he was there. Right, that is the culture we need to inculcate. Like office work, like government office work, we cannot do research. That's where we need to start. That's the first thing we can inculcate from our side. That's why I told you this is like a egg and hen, right? If we want to make a change of this spiral, we need to do what we can do, right? We can contribute at least a bit more, and then we should generate this teamwork and the work spirit and also collaboration. Now what we do is we mostly confront to the isolated research. We are not even discussing with the next lab. We work only within our lab. We try to build our own empires. In science you cannot do everything. You cannot be a professional of everything. You can be a biochemist or you can be a biotechnologist, but you need to make a collaboration. You need to make work with others and also share your things, right? Up here we try to get whole meat. Try karna concept you cannot do that. Then we will not get anything. That's what happens. So that's why I want young generation to think like still work with other people, make your project bigger and invite others also to share things. Now we have certain tools to do this. There are IP regulations, then you can sign NDAs, you can share IP sharing systems, MOUs, you can sign agreements. So it's all protected. So you should not be afraid of things like leaching out. So because if you keep it to yourself, you at the end of the day you will get older, and you get pension, but none of your research get commercialized. So this way we can make certain changes, like bridging the. And also you should talk to the business people and get their advice, and better to include at least one business people in your research team, at least the bigger teams, like maybe the consultation team. They will not bring you a thing. So I personally know that. So I have discussed, they cannot bring, these are not simple. We think that when you discuss with the business people, they will bring you idea and do it, but they can't do that. That's not practical, right? They need you to be there with them. And that's how they can develop the product or a commercial. Otherwise, just giving you an idea or with a discussion with you, they can't go out and do that. That's certain myths that we have within our scientific community regarding the business people. The business people are also having the problem. They are also not innovative. They don't want to go beyond their level of, like in the regime of business. So we need to break from this side, and then only we can get into like a good phase of research. And also research ethics and other things. So we should respect other things, others' research, and also collaborate with others. Next slide, please. Right, these are the things when you are doing collaboration, you can do this both national and international collaboration, and you can collaborate within inter-universities and institutes like ours, maybe the RRI, TRI, these. They are doing research, they are along, we are doing our along. So, but if you are doing some pathological and these things, we can collaborate with them. And another thing is, when you are start research in certain fields, you need to continue it maybe at least 10 years. Now what we are doing, we just completed one research for 3 years and get the postgraduate or a PhD, and we drop that and we start new thing. Right? That will not bring the required quantity of information to make it commercialized. Right. I studied on this Kithul thing for 15 years to make it commercialized. Even after my laboratory work, I work with these industry people for another 3 years to make certain machineries and these things which to my suitability. Right. So that's the major advice I can give to the young people. So if you start even maybe a very small thing, but if you keep it work for a long time, maybe 5, 6 years, 10 years, then you generate sufficient knowledge. Then you cover sufficient ground to make it like sizable, to make it into the commercializable business. But if you do it for 3 years, you generate few papers, 3, 5 papers and a PhD, MSc, but it doesn't cover required space, ground. So that is the best thing, one best thing we can do. We need to keep, I remember my professor in Japan, he did this lipid metabolism for his entire life. Until his death, he worked only this lipid metabolism. Right? What we happen to us is when we do like one day maybe the botany, another day biochemistry, something like that, we keep changing. So that's why we get the publication, other things. That's why it's a bit difficult to make it commercialized. That is the one good thing. And then again the multidisciplinary approach. We should make, not at the beginning, at the right time we need to bring other people to the project. Maybe engineers, process engineers, and also the commercial people, biostatistician, maybe legal people. We have forget that. We need legal people most of them. Maybe the conservators. When you are dealing with biological things, right? We yet to sign the Nagoya Protocol, so we have problems. So you bring the legal people there. Maybe somebody from the wildlife. I have many people from the wildlife working with me because of this issue. Otherwise, I cannot go to the forest and collect the samples. So you share that, then you will be at better ground. So that's the one thing. Other thing, when you try to commercialize, don't think of the big companies. Try to develop your own small company. I think now university can have that facility still. We don't. So you can talk to the medium scale people and start a spin-off, small company, because the big company will not come and buy your technology. That's from my experience. Even you talk to the Unilever or Munchie, whatever the good your technology or product is, they're not going to, they will like just discard you, like they suppress you and feel you like this is not good. That's their policy. Even at the global level, so this is the same. You know, the Google, Facebook, all these companies started at very small, at the garage or somewhere in the computer room, somewhere there. It's not even the pharma. Big pharma products not started from big companies. They started as small companies, but when you grow bigger, then when they see it's growing bigger, they acquire. That's what happened. Right? Next slide, please. Right, even when you select the problem, this is also one good place that you can focus on. When you select research problems, you can select the base theoretical problems from textbooks. That is one way of selecting your research problem. Next thing is you discuss with the industry people. You discuss with the other people, like may not be the industry people. You know, there's a concept called the think tank. Maybe when I work with the Invention Commission, some people, carpentry people, they don't have much academic qualification, but they have very good way of thinking. But that thinking needs certain scientific backgrounds or tools to make it a good innovation. So when you are selecting research problems, even at the university vice chancellor, you can have that. Like maybe your minor staff, maybe outside people, maybe the farmers. They are not scientists, but they will have very good ideas. I proposed this to our management also, but that doesn't materialize. But then you can have that they are not scientists, but they will bring up you certain ideas at the forum or somewhere where you people with the academic qualification, maybe engineers, biochemists, these people can straighten that idea and make it into the workable hypothesis and do research on that. That is one good way of getting research problems into your team, which have higher potential than the textbook-based research to make it commercialized. Right? These are the things that I can share. There is industry, and that's the creative thinker tank, right? That you can do. That's really good things. Now I do with my own small team. Even the institute is not doing that. That's really helpful. Right, next slide, please. This is what this already discussed. This is the concept creation. This is very important. And also, when you are doing one project, again, this to the students. When you are doing a project, you get more problems than answers at the initial phase. So you have to be very careful to pick that opportunities. You should discuss that with your PI, supervisor. And there you get very good research questions which are having good potential, right? Especially when you start at the very, very new project, very new discipline, you get more questions, more problems than finding answers. So there you need to focus on that. Right, next slide, please. Right, then your team. Right, this is also I discussed. Your team at the beginning may be small, but gradually you need to bring up other people, like maybe national collaborators, international and industry people. And also remember that you better somebody with having some idea on IP and intellectual property and business, and also if you are doing the biological things or something that relate to the legal, some legal or legislative things, some lawyer or somebody, you have departments, I think, so you can incorporate that also. Next slide, please. This is what I discussed. When you start, keep it going, right? Don't drop it at midway. And you see, your technology has a time to emerge, right? We call the technology push and the industry pull, right? If you make your invention before the time, you need to keep it, right? If you feel that your technology is, or your innovation is little delay, you have to push it to the market at right time. So otherwise, you can keep, right? This is actually technical things, but you should have some awareness about these things, whether is it a right time or a wrong time to put this to the market and also put to the businessmen, right? This is not a good time to put certain high investment based technologies to the businessmen because they have problems. So you have to keep it and you have to nourish it more and keep it until the right time. Right, next slide, please. Yeah, this is where I already discussed. This is where we need the multidisciplinary approach. Then only you can improve. Actually, you don't need, always you don't need big money. That's all depend on your type of research that you got involved. Next slide, please. Right, this is something like that small case study I will do. Need to finish as early as maybe 5 minutes. So we think that using a botany, you cannot do commercialization. Let's say something like that. Let's say you invent some plant, new plant species, maybe the ornament from Singaraja, which is endemic to Sri Lanka. So what generally we used to do is we report that, we make a publication and enter that, put that into the red list, and we just keep, and we just search for a knuckles or something somewhere else for another new plant. But what you can do is you can work on that same plant to make it like tissue culture and talk with the legislative people and commercial people, some what you call the marketer. Then you can market this into as an ornamental plant. This is what happened to our Binara, right? We just studied the Binara and kept it here. But certain people, I'm not going to mention the country. One country they brought this plant and do certain irradiation technologies and break this seasonality of flowering, and then now they are selling this plant as an ornamental plant, right? So we also can do this, but we need to change the way of our thinking, and also we need to be a little bit patient on that. Next slide, please. This is what, when you have multidisciplinary approach, it's not like that. So we should include all these things, and then only we can make it this into the after. This initial invention is right, the finding of plant, that is the invention part. To make it to the innovation, you need bigger team. You need bigger team, and you should be ready to share your profits or whatever, your credibility or whatever. Then only the country get benefit and we also get benefit, right? Science is really a business. Most of the scientists in other countries are businessmen. Our countries, we just looking for a salary and other things and retirements, right? So, but certain of our findings can be a million worth business. I'm working with one of professors in Korea, marine biotechnologies. He is having 6 companies. All his 6 inventions, he has made that into the spin-off, and he is a director and also the shareholder of the. It's not the 50% share, right? It's not the 50% of share, because generally scientists, they don't have that big money, but still 10-20% of the share in a big million business is a real worth enough royalty. I mean, this money you get back. Next slide, please. Right, this is the story that I'm going to highlight to you on these botany things. You see, this tree is Ginkgo biloba from China. This is one of a live fossil tree endemic to China, which was found to have ginkgocin, very important drug. I don't remember exact date, maybe 20 years back. During that time, only several thousand trees available in Central. I went to this place also. But now even from the Alibaba, you can get this plant. Right? And I went to one factory where they have tons of these leaves of this ginkgo tree, make ready to ship to Germany, because in Germany they extract this compound and make the tablets, ginkgo tablets, not in China. They're just cultivating. The similar, can you identify this plant? This is from Sri Lanka, Salacia reticulata or Kothala. Right? It was found that this is having very unique thiosugar, thiosulfonate, salicylic and mangiferine, which is having very unique antidiabetic property 30 years, 25 years back. Right? Still, it's prohibited to cut any leaf of this plant. If, right? We are not cultivating any hectareage. I mean, I have seen only 25 acres of cultivation in somewhere in Ruhuna, only that. But still, you cannot, if you find having 10 kg of this, you will be in jail. Right? We need to think why. This is the same story. This is an endemic plant. This is a global endemic plant. But this one is available in other countries also. Even it's mentioned as endemic. But this you just check Google. You can get this from Alibaba. This plant, a small plant you can get. This is, if you cut and try to sell, you are in jail. Right, next slide, please. Right. That's why we need to think like this. Policy also come into play, but researchers, we have botanists, agriculture. I'm also agriculture, biochemist, but we did certain research on this but still it's difficult to make it full-fledged because we cannot do agriculture research at ITI. That's why I get tempered. Right? So I have to stop that from certain things because we need to do certain things to do cultivations of this. Right? Next slide, please. We have very specific problems. It takes a few minutes. I like to share this. We have a low tendency of, from our policymaker side, low tendency of accepting local technologies. We try to get it from India or China, and also we have many regulatory mismatch. And the other thing is market size. In Sri Lanka, our market size is small. So if you try to develop product only for Sri Lanka, there is some issue with the feasibility of market. And also, especially when you try to do the manufacturing industry, machinery, we are not manufacturing most of the machineries. We are getting machineries from China and India. Even for cinnamon, whatever, the food processing, all of these industries, machinery we are importing from India and China, their capacities are very huge. We don't have the raw materials to feed to that machinery. That's one issue. And also, we don't have the market to sell with that capacity of output. So then what happens is, most of our factories are running under capacity. Then the business model is fair. Your COP is high. Unit cost is high. So we have a big thing to do with our local engineers we don't need to manufacture that full capacity, but at least to modify that, to suit to our scale. These are the new things I think to you to think. Next slide, please. This is what we did, just 2-3 minutes. This is your pot of Ra. Looking at this, this is illegal, this was illegal, this is contaminated, nobody liked to drink, and all those things. Anybody, if somebody thinks to make export business out of this, he would be crazy. Right? Next slide, next. But I got a very good entrepreneur who was willing to take challenges, and we were able to develop this. Next, click again. So now this is very popular in Australia and New Zealand, and also UK. This like now only 10 months after starting operations, right? We developed this into the wine. This is not white. The toddy is white, but the content inside this is not white. It's something more as a wine. Right, we have ISO 20000 certification and organic certification and forest garden certification, all certification, and we even send this to the Korea, and also now it's very maybe popular in Korea also. Behind that is we did whole bunch of research, and also we developed certain resourcing system for because the raw material is not available that much. But we developed certain technologies and also certain business models to collect it from the farmers and stored in -20 freezers and convert into this wine in a controlled factories where we design the factories, our local engineers design it and fabricate it. That's a success story. That it's not boasting on ours, but just to tell you that if you follow it in correct pathway, so you still can do this. Right? Next slide. These are the final takeaways. Start to think science, experimental research as opportunity for business. This can be done, should be start even from the postgraduate and undergraduate level. And value of multidisciplinary teamwork in converting invention into business. If you want to convert research into the business or invention into business, you must do multidisciplinary teamwork. And a model of quality over quantity. Because in Sri Lanka, we cannot fight in the quantities. With China or India, they are manufacturing huge quantities with low price. We cannot do that. We should think when you are developing product or any such thing in this agricultural biological system, we should think of with high quality, with limited production, high margin. And also there should be some uniqueness to your product. That is the guide, then you don't want to worry about your quantity, because we cannot do, we are a small country, we have small resources. So we have a small market in this country if you focus on the country. So it should be a more over quantity over quality. Next slide, please. If you time, no time. If you permit the time, so we have a video to just check, but I think we don't have time there. This is the company that we formulated for this purpose. So thank you very much.
Thank you very much, sir, for sharing your research experiences with this audience and for your insights on multidisciplinary research and commercialization. To appreciate Dr. Padmasiri Ranasinghe's valuable contribution to this symposium, I cordially invite the Dean of the Faculty of Science, Professor D. H. N. Munasinghe, to present a token of appreciation to Dr. Ranasinghe. Thank you, madam. Thank you, sir. The highlight of the first Ruhuna International Undergraduate Research Symposium is publishing the proceedings of the abstracts. Out of 68 submissions received, 49 have been accepted after thorough review. During the technical sessions, these research papers will be communicated as oral and poster presentations. And I kindly invite the junior coordinator, Mr. Hashen Senaviratna, to unveil the proceedings of the symposium. Thank you all. Now we have reached almost the end of the inaugural session of the first Ruhuna International Undergraduate Research Symposium 2022. And I cordially invite Ms. Eranga Rupasinghe, the Secretary of the Ruhuna Science Research Circle, to deliver the vote of thanks.
A very good morning to you all. It gives me an immense pleasure to deliver the vote of thanks for all those who helped RUSREC 22. First, I would like to give our sincere thanks to the chief guest, Senior Professor Sujiva Amarasena, Vice Chancellor, University of Ruhuna. Thank you very much, sir, for your constant support and kind guidance towards the success of RUSREC 22, and humbly accepting our invitation, joining with us today and addressing the gathering. Next, I would like to pay our gratitude to Professor E.P.S. Chandana, Deputy Vice Chancellor, University of Ruhuna. Dear sir, thank you very much for your valuable input and humble support for us. As always, as the founding patron of the RUSREC, your guidance and strength brought us this far for 8 wonderful years. Then I would like to convey our deep sense of gratitude, Professor D.H.N. Munasinghe, Dean, Faculty of Science, University of Ruhuna. Dear Madam, thank you very much for your input and support for the success of RURES 22. Let me pay our gratitude to the keynote speaker, Dr. Julian Andrew from French Institute, Pondicherry, India. Thank you very much, sir, for accepting our invitation and delivering the keynote address at RURES 22, which is very encouraging and valuable for us. Thank you very much for sharing your experiences with us today. Then I would like to thank our guest speaker, Dr. Padmasiri Ranasinghe, Industrial Technology Institute, Sri Lanka. Sir, we are really grateful to you for making time to visit us and delivering very interesting and important lecture. Thank you very much for sharing your knowledge with us. I would take this opportunity to thank deans, head of the departments, professors, academic staff, acting librarian Mr. Lal Parnila, and administrative staff and non-academic staff for accepting our invitation and joining with RURES 22. Next, I'm thankful for all authors who submitted their extended abstract for making oral and poster presentations at the technical sessions. Without your contribution, this symposium would not have happened. Then, I'm thankful for reviewers and panel members for sharing their valuable time to support us to make this event a success. Dear sirs and madams, thank you very much for valuable support you have given to us. I'm thankful to the Advisory Board of RUSREC, Senior Professor Mangala D. Silva, the patron, Senior Professor Kanti Appa, Senior Editor, Senior Professor Dhammini Premachandra, Senior Treasurer, and Professor Sunanda Kodikara, Senior Coordinator. Your untiring effort, constant guidance, and kind support always a great strength to us. Thank you very much for all what you have done to make this event a success. We are very grateful to our sponsors, AHEAD Project and FSPI Cedric Project for providing financial support for the symposium. Thank you very much for your generous support. I'm so thankful to departments of chemistry, physics, and zoology for supplying us with computers and other technical equipment. Thanks also goes to Dean, Faculty of Science for providing rooms to coordinate technical sessions. I'm so thankful to the alumni of RUSREC, ROC, for giving us courage and motivation in organizing this event. We are very proud that we followed footpaths of you. My dear RUSREC team members of organizing committee, thank you very much for your precious support. I know you all worked very hard day and night to bring RURES 22 to this grand success. Thank you very much. Also, all the members of web team, documentary team, and technical support team, thank you very much for your valuable support for RURES 22. Also, I would like to thank Infoca team and Ruhuna University Media Unit giving media partnership for RURES 22. I would like to thank other non-academic staff, the maintenance unit, and the cleaning staff for helping us to RURES 22 event a success. Last but not least, let me thank Tilini for comparing the inaugural session with much enthusiasm. Once again, I thank our beloved audience and everyone who helped for making RURES 22 as a grand success. Thank you very much.
Thank you, Eranga. And this brings us to the end of the inauguration ceremony. And we hope you all found the session a fruitful one. And I kindly request you all to rise for the national anthem of Sri Lanka. Thank you all. Please let me bring your attention to a few announcements. The technical sessions will commence at 11 a.m. onwards via Zoom. And there will be 6 parallel sessions with oral and poster presentations covering several areas of research findings. And I would like to invite you all to join the technical sessions of the first Ruhuna International Undergraduate Research Symposium 2022 using the Zoom links provided. They are published on the